Good morning all. Now we'll discuss about an interesting topic in matrices. First of all, what is matrix? A set of numbers or elements arranged in rows and columns so as to form a rectangular array. That is called a matrix. In this matrices we have an interesting topic, that is an eigenvalue and eigenvectors. Before we enter into this topic, we should know about determinants and product of matrices. What is determinants? So determinants is a scalar quantity obtained by the sum of product of the elements of a square matrix and their cofactors according to a prescribed rule. Let us consider matrix A is equal to A, B, C, D, and determinant A will be get AD minus BC. Next, product of matrices. What is product of matrices? The product of two matrices will be defined if the number of column in first matrix is equal to the number of rows in second matrix. The resulting matrix will have the same number of rows as first matrix and same number of columns as the second matrix. Okay, let me start with simple example and I shall proceed on to the explanation of eigenvalue and eigenvectors. Let us analyze the product of the matrix A and a vector X. Let me illustrate this with a simple example. I have taken A as 2 by 2 matrix as shown, and we shall consider two different cases for X. In case 1, X is taken as 1, 1. And note that Ax will also be a vector. I have plotted them in a graph for easy understanding and interpretation. Now, what is this graph telling you? Do you see that the resultant vector has been scaled and rotated as compared to X? So, you multiplied a matrix and a vector, you got the resultant to be scaled and rotated, right? Let's now see what case 2 has to tell us. If X is taken as 1, 2, do you see the difference? The resultant is scaled but not at all rotated. A vector that undergoes pure scaling without any rotation is known as eigenvector corresponding to that matrix. The scaling factor is known as the eigenvalue. We know that Ax is equal to 5, 10. Let me take 5 out of this equation. So we get Ax is equal to 5 into 1, 2. And we know this 1, 2 is corresponds to X. Let me replace that by X. And we get finally Ax is equal to 5x. We know 5 is scalar. Let me generalize it. Putting lambda instead of 5, we'll get Ax is equal to lambda x, and this equation is called as a eigenvalue equation. So what is eigenvector? A vector that undergoes pure scaling without any rotation is known as the eigenvector, and eigenvalue, the scaling factor, is known as the eigenvalue. Then Ax is equal to lambda x, where x is eigenvector and lambda is eigenvalue. Some of the application of eigenvalues and eigenvectors. Using eigenvalues and eigenvectors, engineers can prevent disaster. Eigenvalue analysis is also used in the design of the car stereo systems, where it helps to reproduce the vibration of the car to the music. Meridian sound system, which is mostly used in luxury car, are based on the principle of eigenvalues and eigenvectors. Then in mechanical engineering, eigenvalues and eigenvectors allows us to reduce a linear operation to separate simpler problems. For example, if a stress is applied to plastic solid, the deformation can be dissected into principal directions. those directions in which the deformation is greatest. Further applications are vibration analysis, civil engineering, face recognition, musical instruments. Thank you.